welcome to another Generative Components tutorial. Today we're going to have a look at incorporating Excel data into our Generative Components workflow. Excel can be a useful tool to collaborate and update large amounts of data in a visual way. It is also a great way to get other members of the team involved with programs that they may be more familiar with. So let's get started. Starting with a new file based on the neutral metric design seed file, let's drag in an Excel node into the graph window. If we zoom in, you can see there are three standard inputs, the first being the workbook file. Clicking on the input, you can see there is an option to browse for a file by clicking on the three dots, but you can also type into the box. And I'll just type in excel_data.xlsx inside inverted commas. I don't require a path as I've located the file in the same folder as my DGN I'm working with. The next input is the sheet name. And this is just the name of the sheet in Excel. And I have not changed this from the standard default, so it'll be sheet 1 inside inverted commas again. Now for the next input, you'll need to know the range of data you're looking at. If we look at the data I have column A through to column E with different values in each column. I have distance, angles, parameters, integers, and text. And they each have 10 values, starting with row 2 and ending in row 11. So for the range, let's input A2:E11 inside inverted commas. Now if we click on the down arrow on the output, we can now hover over the value output and we can see an array of data has been populated. But it isn't exactly what we were looking for, as it is reading row by row, not column by column, as I've set it up in Excel. So let's pin out that value output so we can use that data in some other operation. And let's drag in an operation node. We can link up the value output to the operation node and we can see the values appear in the dialog. The operation node is a dynamic node and it filters the possible methods by the type of input it receives. For our situation, we'd like to transpose this data so it's grouped by columns rather than rows. So we can start by typing that in and select transpose from the list. And now we have the data in the format we'd prefer. Now we can use this data as it is and link this operation node as an input and target just the indice reference we need, but let's make it a little bit easier to deal with. First of all, let's rename the operation node to Excel Data Transpose. Let's drag in a new operation node and clicking on the down arrow from the Excel Data Transpose node we just made, and let's pin out the value so it's easier to link up to the new operation node. Now for the method of this operation, let's type in index and let's select the I in square brackets index from the list. This provides us an I input, that is the index, or from our situation, it'll be the column of data we'd like to filter out. As indices start from 0, let's start with the 0 as the first input. Now we can see we have a simple list of data that shows us just the distances that were from that Excel column. So let's rename this to Excel Data Distance. Now for the other columns of data, it is simple as right-clicking on the node and selecting copy and then selecting paste. And now you can do that a few more times so we have a node for each of the columns of data we need. Now we just have to change the index for each of those nodes and rename them so we can clearly see the data in each node. And when we're finished, we should have separated all the Excel columns into individual nodes. We've got distance, angles, parameters, integers, and text. Now we have all the Excel data separated into usable nodes, let's look at the imported data. If we look at the Excel data integers, you can see the values are not really integers, they are decimals or doubles. This is a common issue when importing data from Excel. Let's look at how to convert these values back into integers. There are a number of ways to achieve this. The easiest I've found is to click on the functions icon on the ribbon, which is located on the model tab under calculations. This will open up a dialog with all the standard functions Generative Components has to offer. Looking through the list, you can see a function called toInt. To use this function is as simple as clicking on this and dragging it into the graph window, and it'll create a new function call node with toInt as its function. Now all we need to do is link up the Excel data integers up to the input on the function call node. And you can see we now have integers. Let's rename this node to Excel toInt, and now we can close the function dialog. Now we have all the data in the correct format, let's see how we can use this data. So switching back over to the Home tab on the ribbon bar, let's click on the point tool and click Yes and OK to create a base CS. Now we can cancel that point placement and relocate the base CS node so we can easily see it, and let's drag in a line node. Zooming in a bit, let's change the line node method to by start point direction and length, and we can link up the start point to the base CS. For the direction, we can click on a direction from the base CS in the view, or you can simply type in basecs.x direction. And for the length, let's use 15,000. Next, let's drag in a point node and change its method to by distance along curve. The curve will be the line 1 we just created, and for the distance along, let's link this up to the Excel data distance that we have. And now we can see we have a series of points at the distances set out in the Excel document. Now let's drag in a coordinate system and change its method to by origin rotation about coordinate system. And for the origin, let's input the point 1 node. The coordinate system has been automatically linked up to our base CS, which is fine for this example. And for the axis, let's set that to Z. And finally, we can link up the rotation angle to the Excel data angles. Now we have a series of coordinate systems that are rotated about their Z axis of the base CS. The number of coordinate systems is also equal to the number of points we use at the input, and the angles are then linked up to the corresponding Excel values. And if we change to the plan view, you can see this a lot better. Now let's have a look at the next data type. We could do this by simply changing the method of the point node we have to by a parameter along curve, and linking up the T input to the Excel data parameter. The points are now updated to be spaced by the parameters, but it still keeps the coordinate systems attached and rotated. Integers work in the same way, but it just gives you a different type of data to work with. And I'll leave this one for you to experiment on how to implement this into your workflow. They can be very useful when trying to select a value from a list where the input requires an integer. So finally, let's look at that Excel data text. For this data type, we need to drag in a text node. For the placement, we can link this up to point 1 node, and then simply link up the text value input to the Excel data text. And now we have text next to each point. If you wanted to take this one step further, you can drag in a text style node to control the exact placement and formatting of that text. Hopefully that gives you an understanding of how to use external data from Excel in your design workflows. In the next video, we're going to take a look at the export node and how to export specific nodes or outputs to a standard DGN file for other team members to use. Thanks for watching, and I'll see you next time.